as many of those questions at the end of the webinar. So without further ado, I would like to go ahead on and introduce the speaker of the hour. Mark Horstman is the project manager in the WK Dixon Watershed Services Group with an emphasis on municipal stormwater infrastructure, including planning and design, hydraulic and hydrologic modeling, innovative and sustainable site design, and stormwater BPM design. He has both an undergraduate and a Master of Science degrees from the Biological Engineering Department in North Carolina State University, and is a registered professional engineer in Tennessee, Georgia, North Carolina, and South Carolina, and is also a certified professional hydrologist and a certified floodplain manager. Thanks, Mark, so much for taking out time, and you have the floor.
Thank you so much, Michelle, and thank you to everybody who's attending this webinar. It's actually been about a year since I was participating in this webinar, actually talking about the Caswell Beach Dune Infiltration System. So I'm sure many of you who are logging on are like, wait, is this just a repeat of last year? And I promise you it's not. We're not entirely. In fact, over this past year, we've constructed this system, and so this presentation is going to kind of wrap up some of the, a lot of the construction of it, some of the challenges we faced during construction, and also videos of how well it works. So for those of y'all who have seen this presentation a year ago, just hold tight for the first couple minutes. I'm going to provide a background and some background information on the project, but hopefully there'll be some new and refreshing material with it. And today we're going to talk about the Caswell Beach Dune Infiltration System, which is kind of a newer technology for coastal towns and communities. I think it's a successful case study for some innovative coastal resiliency solutions, especially as we are looking to address some of the upcoming challenges on the coast and implement more resilient solutions. Okay, so the town of Caswell Beach, as many of you probably know, is located in Brunswick County. It has, one could say it has two populations, right? One during the wintertime and one during the summertime. During the wintertime, it has about 420 year-round residents. And of course, that significantly increases during the tourism season, starting in the spring, ending in mid-fall, where we have, the town has about a seasonal peak population of 2,400 people. So it is the home of the Oak Island Lighthouse. So Oak Island Lighthouse is located in the town of Caswell Beach. Right? It's also the home of a Coast Guard station and the North Carolina Baptist Assembly. So I want to play this drone video here. This is a nice purview of almost the entire town from a drone video. And as we're kind of watching this video, just kind of start thinking about a couple of things. One, you have a major tourist attraction from the Oak Island Lighthouse. Two, you only see one road on the entire island. So one way in, one way out to this major tourist attraction. Also, you have the North Carolina Baptist Assembly there at the end of the island. The Coast Guard station located right next to the lighthouse. Of course, there's a emergency access for the Coast Guard. But one of the benefits that town of Caswell Beach does has is pretty wide beaches and a pretty robust dune system. You have primary dune systems and secondary dune systems along the stretch here. So this is one of the few beaches in North Carolina where actually sand is being added onto the beach and compared to a lot of the erosion that's happening. So, and kind of flying the dune, they in this section of Caswell Beach, there is that wide dune system. So since we're talking about dune infiltration systems, what a great location and opportunity to implement this technology. So, excuse me. And talking, just kind of as a recap, here is an aerial photo of the entire town. Looking from, here's the golf course. This is the Duke Power nuclear power plant. The effluent from the hot water discharge from the Brunswick County Nuclear Power Plant, just kind of right outside the screen here. Here are residential areas, the Coast Guard Station and Lighthouse is located right down here, and here's the North Carolina Baptist Assembly. To the west is Oak Island, and of course to the right, the Baptist Assembly is located at the old Fort Caswell. So then kind of zooming in, we talked about it, there was only one road, one ingress and egress. And along that road, from moderate to large storm events, in 5 major flooding locations, the town experiences significant ponding. And so what do I mean by significant ponding? Well, here's a picture of it. It can rain not even half an inch, a quarter of an inch, and you get ponding along the road right here at these 5 different locations. So you can imagine with only one way in and one way out, if an emergency happened, okay, well, we need to get a police car, ambulance, fire truck down this road to help provide emergency services to the residents. So now, looking at this picture, I'm sure everybody here is like, oh, well, we can just drive through that, not a problem. But just as a reminder, in the moderate storm events, that ponding depth is about 6 inches, or maybe a little less than 6 inches. Severe storm events, of course, the ponding depth gets higher than 6 inches. And you ask them why the focus on 6 inches? Well, around 6 inches, you start losing vehicular control, or you can start stalling your vehicle depending on the type of the vehicle you have. After about 12 inches, depending on the vehicle that you have, your vehicle starts to float. So while you might have some larger vehicles like fire trucks that can push through some of this wall, some of these small vehicles, you do run the risk of stalling and losing control. Which is why, since this is recorded and this is put on by the state, I'm always going to say, hey, please don't drive through flooded areas. Turn around, don't drown. And if you do have flooded roads, let's make sure that we close them to help reduce potential accidents. But you can say, hey, wait a minute, if we only have one ingress and egress, it's kind of hard to take that particular advice of don't drive through it when there's only one way in, one way out. So we've been working with the town of Caswell Beach for a while in ways to kind of help address that particular flooding issue along Caswell Beach Road. As we were looking at different alternatives, we kind of thought back to some other solutions that have been implemented up and down the coast. One of them is a way to help resolve these stormwater discharges. So sure, one would think, well, why don't you just take the flooded water, pump it down, and pump it out into the ocean? And in some cases where you have stormwater discharges, hey, that by gravity, the stormwater discharge flows right out into the ocean. But you'll notice if you go to any one of these discharges, here's a giant sign that says, hey, do not swim in this area. Bacterial levels indicate, bacterial levels after a storm event could be high. In some cases, the state has to come in and for public health reasons, shut down the beach. So you can imagine if you're a coastal town, and you rely on tourism, you really don't want to have signs that say, yeah, please don't swim here. We gotta shut down the beach. So looking back at some research that NC State did, they actually installed some dune infiltration systems to try to help remove some of these coastal outfalls. So looking back at some of the past research, these dune infiltration systems were actually very effective at reducing the amount of flow, infiltrating the amount of flow that goes through their system. So in referencing back to this report, for one of the sites had 96% of all flow get infiltrated. The other site, which was slightly smaller, had about 80% of all the flow that got infiltrated. As an additional benefit from a water quality perspective, they actually found that 98% of all the bacteria from this ocean outfall that would cause beach closures actually decreased by 98%. So as we put in these stormwater control measures, we try to focus on water quantity and water quality. There's research that indicates, hey, these dune infiltration systems serve both functions. So we said, well, let's see if we can utilize dune infiltration systems, if it's even feasible, to help address the problems that Caswell Beach had. So we did work with the town to do a feasibility study back in 2018. And ultimately, the first pass that we looked at was saying, hey, do we have space that we could put in dune infiltration systems? Yeah, as the drone video that we saw showed, there are primary and secondary dune systems along the wide beach. However, most of that area is owned by private property. In fact, oceanfront private property. And even though we, and GIS and the aerials, it looked great. Oh yeah, this site looks great. We have the space to be able to put in these dune infiltration systems. Once we approached the property owners and talked about the impacts to the property and perhaps construction and trying to obtain easements, even kind of laying out maps where we said, hey, we could have permanent drainage easements or temporary construction easements, and here's what the system would look like. We didn't really get a lot of public buy-in. We tried, but we didn't really get a lot of public buy-in. However, after further consideration, we did indicate, we said, hey, well, the town does own some beachfront or some dune property right across from the Oak Island Lighthouse. Specifically, I can't see my mouse, where they just put in a new parking area for people to walk on a boardwalk to go visit both the beach and the lighthouse. So we said, hey, well, let's evaluate if perhaps we could use this primary dune system and pump the water from the low spots into this primary dune system. So it was tough. I had to take a lot of trips to the beach for this project, but somebody had to do it to evaluate the site. But in kind of looking at the dune topography, again, the primary dune system and the secondary dune system, we did lay it out and say, well, if we were to take all of the flooded, look at all of the ponded areas along Caswell Beach Road, look at the total volume within these ponded areas, could we put in a system big enough to infiltrate that entire volume and potentially draw down? We did realize that we couldn't do a gravity system. We would have to pin in a series of pumps or have pumps come and pump the water down due to the relative elevation both of the water in the road and the dune infiltration system. But looking at the space available, we said, hey, we can, for about 105 potential chambers, we have the space, we could put this system in. So we proceeded forward, got the topographic survey, created design plans, laid out the system with 105 total chambers, and ultimately the design capacity to infiltrate about 1,000 gallons per minute. So here's a quick animation of this particular design and kind of how we set it up. So when water ponds in the road, we would have a pump system come in, or a pump. It would pump it to the proposed dune infiltration system. The water would come up into the dune infiltration system, fill it up, and then infiltrate down into the surrounding sand. So, of course, if for anybody here who's worked with infiltration systems, whether that be bioretention areas, whether that be linear infiltration galleries, you got to have a separation between the bottom of your device and the seasonal high water table, and you also have to have media that can infiltrate well. So using some of the guidance out there, we did say, well, hey, let's target to have a 2-foot separation between the seasonal high water table and the bottom of the dune infiltration system, which means that we want to make sure we had enough cover over the dune infiltration system, have enough vertical distance for the chambers themselves, and also ultimately have 2-foot separation. So you start doing the math here. Okay, so that's 2 foot of separation. The chamber is about 3 foot high, and we want at least 2 foot over the top of it you're getting to be about 7-foot vertical clearance. So when we talk about, hey, do we have the space to install these systems? You're not just looking at the horizontal space, but also do you have the vertical depth above the seasonal high water table? And then we also said, hey, let's discuss. So one, how do we measure the seasonal high water table? And also the surrounding media, sand, does it have the infiltration capacity or the saturated conductivity? So we did take soil borings. We took about 6 different soil borings at this site location. The soil borings did indicate we did have this separation of the seasonal high water table. And we also had, I didn't pin it on there, but we also had the saturated conductivity of fairly high. So we all know that water can flow through sand pretty high. And the saturated conductivity ranged from about 20 inches per hour to about 28 inches per hour. So if you can get the water into the sand, it will infiltrate fairly quickly, as any kid on the beach can tell you. Recognizing that we were pumping a lot of water into these infiltration chambers, we did perform a groundwater modeling analysis to look at the infiltration mounding. So the last thing we wanted to have happen is, okay, well, let's pump a bunch of water into this dune system, and then water then infiltrate it back out into the road and flood the road. Also, we wanted to make sure that between this entire property is owned by the town, we want to make sure that we were not pushing groundwater from the mounding of the system onto adjacent property, maybe impacting building foundations or anything like that. So we wanted a groundwater model to indicate if the system would work. So looking at, this is the kind of the output of that calculation. The groundwater mounding does stay within the project site. So another thing we checked off the list there. Again, looking at the horizontal distance between the road and the property lines. So some further considerations that we had to take into account both during the design and also when planning for construction. The other part about that is we had to also time construction, both not to impact tourist season. So just kind of looking at this picture, here is the new parking lot that serves both the Oak Island Lighthouse and the beach. And this is a free parking lot for visitors to the town. But the other component of it is protecting sea turtles. We didn't want to have construction happening both midsummer all the way to mid-fall during sea turtle nesting season, since sea turtles do ultimately come up close to the dune system, not in the same location as our project, but nearby. So we had to kind of schedule construction ultimately near the middle of winter or the beginning of the year. And the other consideration that we had to work with was working with CAMA. You know, you just can't go out with a backhoe and just start digging in the dunes. That isn't illegal. So we had to work with CAMA to kind of discuss what this project was, the benefits provided by this project, and work with the state. And they're great folks at CAMA. I really do appreciate their efforts to kind of make this project successful. So what about cost of this system? Show me the money, right? So this cost was back in 2019. So and I recognize the bid market has significantly changed back when we put it out to bid in 2019. But so, and just as a note, you know, somebody's taking notes saying, well, hey, wait a minute, Mark, you said you built this at the beginning of 2021, but you bid it in 2019. And that's true. We put it out to bid in 2019. And the winning contractor, there were some issues with some of the funding components of it. Part of this project was funded by the NCDOT. I think we all remember back in 2019, there was some funding things that came up with the NCDOT, but back in back in late 2020, they said, hey, we're ready to move forward. The contractor was kind enough to say, hey, we will honor our price and we will be happy to build it for that price. So, well, if our engineer's estimate for this project was $282, not $282, $282,000 for this project. We had, I believe, 4 bidders, and here's the range. So the contractor that actually provided the $254,000 was the low bid contractor, and since they were local to town of Caswell Beach, they kind of knew everybody. They wanted to see the success of this project. They were more than happy to hold on to that price almost about a year later to construct it for that amount. And no, they didn't hit us up for change orders, and the final construction cost was about around the $254,000 mark. So, but one of the things, whenever I see a spread like this in bid values, I'm not too shocked because this is a relatively new project or relatively new system. So some contractors were kind of adding in risk with that. So we did go with the $254,000 contractor. So talking about contractors, let's talk about construction. So here is the excavation of that primary dune system. So we, just as a reminder, we put in three rows of chambers, both totaling to 105 chambers. You can see kind of stacked right here in the center is well, the chambers. They were about 3 feet high and about 5 feet wide. So Hickman Utilities was the contractor who installed this, and we're very thankful for having them as a team partner. The overall construction, I'm going to flip back to this. This picture was taken about the first week of January of this year, 2021. And because of the ease to construct it, it took them about 4 weeks to construct this entire project. So very fast turnaround because these chambers are fairly light. In fact, I mean, we see here who's and backer holding it up, but those 2 individuals could actually pick up those chambers and place it. And they stack on top of each other. So right here, there's a picture of them kind of stacking them end on end, pitting it on top of filter fabric. So we have 2 feet of number 57 stone on the bottom, filter fabric on top, pit in the chambers, and then we have stone that kind of goes up to the top of the chambers. And once they were able to set up the rhythm and they had survey control out there, they were able to install, I'm going to say about half of a row. And within 1 week, they installed the majority of the chambers. And I said total of 3 weeks construction. We had some other drainage systems, and we also had to connect it into the force main to pump it. But as far as the chamber installation goes, they had great weather, and within a week they were able to install all the chambers. Here's a drone shot of them installing looks like to be the middle chamber. And you can see kind of from this picture right here, we did use kind of some standard DOT catch basins or junction boxes, excuse me, to help when the flow comes into the system, kind of help diffuse the flow out to the different chambers. Another picture of them installing, again, just kind of once they got the system down, they installed the stone, unrolled the filter fabric, and pit in the chamber, installed the chambers. Here's a good cross-section view of the chambers. Kind of they're sitting on the filter fabric. Again, the chambers are 3 feet high, 5 feet wide. I'm a big guy, so I couldn't crawl through it, but some of the other folks, just as they were installing, they did inspect the seams to make sure that the seams were constructed. And you can imagine, I like this picture because it shows when water is kind of flowing in there, if you get a huge volume, you can imagine water filling up to the top and then infiltrating down. So I'm sure there's a question out there and saying, well, hey, what about maintenance? You put in filter fabric, there's going to be debris that clogs up the filter fabric and you have to rip it all up. Well, the way we set it up is to where it should be accessible through a vacuum truck to come in and vacuum out any of the trash or debris that might start to accumulate on the top of that filter fabric. Here's a picture of the constructed dune. We tried to match the existing topography as not to disrupt any of the floodplain limits out there. So actually in a VE zone floodplain. So if we're matching the same topography, we did a no-rise. If we had to change the topography, we would have to have a series of changes within the flood map. So it's just easier just to kind of match the existing topography. Again, the dune was high enough where we had that at least 7 foot. In some cases, we actually had more vertical clearance. All right, so sorry, this picture was taken, I'm gonna say the beginning of February. This next picture, we did go in and plant with native sea oats. And so I'm gonna say this picture was taken about early April. So sea oat vegetation establishment is critical to maintaining the dune topography and dune health. So once we completed it, and once we confirmed the topography, we almost immediately started planting to get that root vegetation in to kind of start keeping that sand in place. I want to point out, there is another dune infiltration project at the town of Kerr Beach has one. They have a great educational sign out there. And so ultimately the town, as part of their stormwater education program, will start adding in additional signs along the boardwalk right next to the dune infiltration system to provide that public education component. So we talked about pumping the water to the dune infiltration chambers. Here's a picture of the 4-inch pump that they bought. And they're going to put that on the it's a trailer, and so they're going to use the fire truck and during storm events to take that pump, put it behind the fire truck, take it to the flooded areas and start pumping those flooded areas down. So in fact, here is the fire truck. One of the fire trucks, actually that's the Southport fire truck, but they have a very similar one for the town of Caswell Beach. This is a picture of us actually testing the system. So you can see kind of in the left-hand side, we were kind enough to, the fire department was kind enough to fill up a inflatable pool. And ultimately use those to test the pump system and test the overall infiltration capacity. So here's this picture here is one of the ports. So we have 5 ports, each one for the low areas, low flooded areas along Caswell Beach Road. And here's a picture of it. We turned on the pump on the far end of the island at the first, where the fire truck at, where the fire truck was at. Waited a couple minutes, and sure enough, water starts flowing into the distribution box going into the chamber. So I want to show this video here. So this is at the beginning of the test. And this, the water here flowing out of this pipe, you'll notice there's 1, 2, and there's actually a third pipe through here. So this is acting like a distribution box where the water will first flow through the middle chamber. And then when it gets high enough, it will start flowing through the other middle chamber, the first row of chambers. And then when it gets high enough, it'll start flowing through the other 2 chambers. So what you're looking at right now is water flowing into the first series of chambers, first row of chambers. So, so as you're watching this, just think about it. This is about how much flow this system is going to be taking in when using this 4-inch pump. We still haven't had enough flow to where it's entering into the other 2 rows of chambers yet. And that's kind of what they're inspecting right now. Still a lot of water going. It was a lot of water. But this is a test, right? So the hope was is we could test it out this, figure out, does it work? Is it going to fill up the chambers completely full of water? And then pretty soon they'll go in and look at the far end of at the whole row of chambers and see how much water is in the end of the row. So they will walk into the end of the chamber. Oh, sorry, the end of the row of the chambers. Looking down, this is the inspection port. And both looking at both of the inspection ports for this particular test, and they pumped a lot of water into the system, and there was not much water discovered or determined at the end of the chambers. So the test itself was quite successful. There's a lot of water infiltrated within the system. So this is a photo of taken actually on top of the Oak Island Lighthouse, looking down at the new Dune system. And of course, it's located near the boardwalk to provide that educational opportunities. But also you can see the sea oats are starting to establish. Again, I think this picture was taken, I'm going to say May. Here was a picture taken a couple months ago, probably, probably early September. And you can see the sea oats have definitely been established well, and the root system has been established well. In fact, almost to the point where if you didn't have any signs, nobody would really know that, hey, this is a resilient stormwater practice. So I have some additional resources for folks who either maybe if they want more information. I don't know, Michelle, can I share these links out to everybody?
Yeah, can you share the the links? Yeah, you can yeah, like afterwards you can definitely like just send them to me and I'll put them on the website.
Okay. Well, I guess actually, I wonder if I can put it in the
Or
chat.
yeah, or you can even put them in a chat if you have access to them now. You can drop them in a chat.
So there's one, and then oh, let me go back to the presentation here. Okay. Oops. Okay, so the links I just shared, one is a article within the Stormwater Solutions magazine, which is ultimately providing more detail about this project, and kind of some quotes from the town. The second part is a YouTube video that we put together that shows similar to what I showed in this presentation, but kind of how these dune infiltration systems work. I will note that we're also working with the town of Oak Island and town of Surf City to implement these dune infiltration systems. Noted for town of Caswell Beach, and just due to the topography, we had to pump the water into the dune infiltration systems. Sometimes you can find situations where you can actually have gravity fed into this dune infiltration systems. Okay. Get back to the presentation. Okay, so I'm gonna put this plug in for a future vision here. So here are my kids playing by a pipe outfall. You know, I know I probably shouldn't have them playing by pipe outfall, but yeah, one of the visions I can see with these dune infiltration systems is now the ability. We now have another tool in the toolbox to get rid of these ocean outfalls, to get rid of these signs that say, hey, sorry, you can't swim at the beach because it just rained and there could be high bacteria levels. Or we can, another tool in the toolbox here to help us address flooding in the road and improve water quality. So, and with that, we have another successful example of where these systems do work. So with that said, it's about 11:40. So I'll be happy to help open up the questions. here's my contact information, my email. You're welcome to take a screenshot of that. And if I'm not able to answer your question during this session, I'll be happy to email me. I'll be happy to respond by email.
Okay, so Mark, we'll start with the first question that we have. It says, what is the anticipated life expectancy of the plastic infiltration chamber?
Yeah, you talk to the plastic suppliers and they're going to be like, this thing lasts forever. Okay, thanks. Our goal is to have about a 35 to 50-year lifespan for these systems. So both with the concrete, the HDPE, so the concrete structures are putting in, the HDPE pipes are putting in, and then those plastic containers, they all said, it should be about within 50-year lifespan, plus or minus. Now, hey, let's all 50 years from now, let's all kind of take a look back at the system and see if that was true or not. But that's at least from the specifications that they provided us.
Okay, so the next question is the fill over the chamber systems just sand, or is it soil compacted, stabilized to help with the potential of the sand on the dune being washed away or eroded?
Yeah, no, this is a great question, and that was one of the discussions that we had with CAMA. So great question. And in fact, to maintain the natural, excuse me, kind of maintain the natural formation of these sand dunes, we try to use as much sand as possible that we dug out from the dune to replace it back on top. And where we said, hey, to keep that sand in place, instead of using some type of compact fill, we're going to use it as with vegetation and do vegetation stabilization. So just again trying to match the natural landscape as best we could.
Okay, so we have another question. For the treated stormwater, were there any discussion about bacteria or contaminants leaching, migrating over times towards the ocean?
Yeah, because that'd be embarrassing, right? You take all this stormwater, you pump to the chambers, and now you start polluting the ocean from it all infiltrating. And prior to us really kind of recommending these systems, I looked way back at the research that NC State did, and that's published journal articles, where they did look at how far from the point source of the infiltration, how far out do the bacterial levels or any other type of leachants, excuse me, what the percentage is. And they found about 50 feet, plus or minus, about after 50 feet, the bacteria levels are, it match what the background bacteria levels are. So similar, and I don't want to say this is a septic system, that's not what I'm saying, but again, similar biogeochemistry happening as you would find from the septic field as the water infiltrates in through the soil. Similar, but not exactly the same.
Okay, we got another question here. Do you include monitoring port cleanouts at the dead ends of the chambers?
Yes, we do. And I was maybe going to try to find a picture of that. So somebody asked that. Here's one right here. Yeah, so we have, so if you remember, there are 3 rows of chambers. On 2 of the rows, we have manholes. On this main row, we have this clean out inspection port. And so from the video, if you remember, they actually did pop both the manholes and the inspection ports to kind of look down, see what was in
there. Okay, let's see. And we have a gentleman says, maybe I missed it, but is there an overflow for the system? Is there a gravity drain pipe for the draining the system if it plugs?
Yeah, so yeah, good point from an overflow. If you have a gravity drain system, you definitely want to include an overflow within it. Since this is a pump system and we can control how much water is flowing into the system itself, we don't have an overflow because we are controlling how much water we're pushing into the system. So the current agreement we have with the town is when they do utilize the system, hey, make sure that we're checking the inspection ports and the inspection manholes and make sure the system's not backing up. And if it does start backing up, kill the pump, let's figure out what's going on.
Okay. Do you look at velocity dissipation in the inlet area of the chambers, or is the filter fabric rated for velocity?
Yes, we did look at the velocity of that water coming in, and hopefully I can kind of show. There we go. That's some velocity going. We did look at the velocity, the anticipated velocity coming out of this water, and the filter fabric is rated for that because, of course, we didn't want a situation where we start pushing water through here and it starts eroding out this section, as you can see from this, from the high amount of velocity that we're seeing with this photo.
Okay. And what are the implications of sea level rise and increasing groundwater elevations for these kinds of systems?
Yeah, it's a good question. And so ultimately we set the system to have 2 foot of separation. And in fact, and I say 2 foot, in some of these cases, we actually have more than 2 foot. Yeah, and in sea level rise, we can definitely expect the seasonal high water table to continue to increase, and maybe you only have ultimately a 1 foot separation. Not to get too technical, you can look at some of the guidance though and say, hey, 2 foot's the recommended. In some cases, if you only have a foot of separation, do you still have the infiltration capacity to infiltrate that out? Because of course, it's not just water actually I'll go to the mounting analysis, right? It's not just water infiltrating vertically down, but it's also horizontally infiltrating out too. Now, with that said, now I'll even try to address the question of, somebody asked me once, hey, what if a hurricane comes in and just completely erodes out the system? And I said, well, that's true, but at that point, the road would be eroded out too, so you kind of don't have to worry about, flooding on the road anymore. So this, these are not permanent solutions to a lot of the changes that are happening on the coast. This is just another tool in the toolbox.
Okay. Can you speak more about the plastic chamber material with more concern about plasticizers leaching from the degrading plastic? What other materials might be used for these practices to protect the coastal environment?
Yeah, and that's a good point too. So what if you have this plastic material and it does start to degrade and start to make its way into the groundwater? With that said, we do try to, this material is made out of HDPE, like a lot of the water lines on the coast as well. So we're trying to use as best as we can, within our specifications, use some of the strongest durable plastic materials, or the HDPE materials. We're trying to stay away from necessarily, necessarily metal materials that could rust easier within the salt water. I mean, you could put concrete systems in that could provide kind of the same function, but putting in concrete will take longer for installation and could or could not be more expensive.
Okay, Mark, I think that concludes all of the questions that we had for you at the moment. Is there anything else you would like to share, add to your presentation? Or you pretty much covered everything?
No, again, just appreciate everybody's time to sit in this presentation. So again, I'll provide my email should anybody have any further questions.
Okay.
And please also take a look at those links that I shared as well.
Okay. Thanks again, Mark, for your time. We really appreciate it. Mark is going to share his presentation with me, so we will definitely have that along with the recording up on the website. So if you want to go back and review some of his slides, we'll definitely have that up hopefully one day next week before we all go on our break. And then just want to give you guys just a little heads up about our next webinar, which is January the 19th. It's going to be about the New River Estuary Ocean Highway, Oyster Highway, and basically it's paving the way for stormwater treatment. And Pat Donovan will be leading that one. And again, I just thank you guys for taking out the time. And we wish you guys happy holidays, safe, and enjoy the time with your family. And happy New Year to each one of you. And we're looking forward to some spectacular webinars starting in January. So you guys have a wonderful day. I've dropped the link below for the PDH credit. And you guys just enjoy the rest of your day. And we talk with you soon. Thanks so much, Mark.
All right, thank you.
Bye-bye. And to everyone that's still logged on, I dropped the link again in case you missed it earlier to complete the evaluation for your PDH credit. I won't be able to complete that unless I have the evaluation completed. So I'm going to hang out leave that link down there until 12, and then I'll end the meeting for everyone. Okay. Thanks.